Here we want to discuss in this example, function is fxy is equal to 3x to the power 4y cube minus 4x squared plus 4y cube plus 5. Want to find the first partial derivatives. Now, want to find the first partial derivatives mean either we take the partial respect to x or we take partial respect to y. First, I take partial respect to x. When I take partial respect to x, then the y is constant. So here I can just show you that here y is constant. So we just make it yellow. Also, is y is constant, make this term yellow. Also, 5 is constant for x, also for y. So what's changing? Changing is only x. So when we take the partial derivative of this one, so I write here f of x, that's derivative with respect to x, y is taken as constant. So what we'll get? X to the power 4, use power rule, 4x cubed, 4 into 3 is 12. Here 12 x cubed, no change in y. Y remain itself. Then our x is changing, we have 4x squared, derivative x squared is 2x. So get it 2 into 4 is 8x. Now 4 is constant, y cube is constant because we are changing with respect to x only. So derivative of this one is 0. Then 5 is a constant, so derivative of this one is equal to 0. I simplify this one. My result is 12 x to the power 3 y to the power 3 minus 8x. So this is my derivative with respect to x. Now I move next and we find here the first partial derivative with respect to y. So we write here first partial derivative with respect to y. Then obviously we have the function here is fxy, and that's equal to 3x to the power 4 y to the power 3 minus 4 x to the power 2 plus 4 y to the power 3 plus 5. Now what we are saying, we have changed only with respect to x, or y is constant. When y is constant, then obviously we having here now our x, this value, x is not contributing anything. Here the value of x, we are going to block that one, and 5 is constant all the times. So when I want to find the derivative with respect to y, xy, so my x4 is constant, 3 is constant, only y is changing. So y cube derivative of y cube is 3y squared. 3 into 3 is 9, x to the power 4 y squared minus. This will be 0 because x is constant, 4 is constant. Now y is changing, so get here 12 y to the power 2 and plus here 5 is constant with 0. I simplify this one, I get my result 9 x to the power 4 y to the power 2 plus 12 y to the power 2. This is my final result. So I get the partial derivative with respect to x, and I get here partial derivative with respect to y. Here y was constant, here x was constant. I take another example, and here is my function x into e to the power x y squared. Want to find the first partial derivative and find their value at the point 1, 2. First we find the first partial derivatives, f of x and f of y, and then we find their values. I want first find the first partial derivatives for x with respect to x. Now with respect to x, you can see here we have the function is a product function. We have having here x and we have here x. So use here product rule to solve this one. The first function x into the derivative of the second function, that's e to the power x y squared, and then the derivative of here the function with respect to x of x y squared plus. Now we have the derivative with respect to derivative of the first function x is 1, and we get here e to the power x y squared, y is constant, and we can just rewrite here, this is my x, e to the power x y squared, and then derivative, the partial derivative. X is changing, y is not changing. So derivative of x is 1, we get here y squared, and then we get here e to the power x y squared. We simplify this one, we get here x y squared into e to the power x y squared plus e to the power x y squared. So this is my first partial derivative with respect to x. This is my result one. Now I can find the value of this function fxy at the point 1, 2, x equal to 1, y equal to 2. We get here 1, we get here 4, and we get here e to the power 1 into 4, and we get here e to the power 1 into 4. So when I simplify this one, get here 4 e to the power 4 plus e to the power 4. We take e to the power 4 common, and get here 4 plus 1, and that gives me 5 e to the power 4. This is my result. So this is here my result for fxy at the point 1, 2. Now next is, this is my first result. My second result, I want to find the partial derivative of this one with respect to y. So here, now you can see it here. When we take the function xy, y is appearing only once. So there is no product rule which is going to be applied. X is constant. So we get here x e to power x y squared, the derivative of xy squared, into derivative of this one with respect to y of xy squared. Now x is constant, so only y is changing because there was only y term appearing only once, so we don't need to have the product rule. We just take x as a constant, e to power xy squared e to power u, that's e to power u into du by dx. And here we are taking partial with respect to y, so we say partial y. So here the derivative of e to power, we get here x e to power xy squared into, now the x is constant, y is changing, y squared derivative is 2y. So get here 2xy. We simplify this one and we get here this equal to 2x squared e to power x y squared. This is my result 2. Now I want to find the values of the function f(x,y) at the point 1, 2. So we put here value of x is equal to 1, y equal to 2. So get here 2 into x equal to 1. Here is x equal to 1 and square is on y. So we get here 1 and y equal to 2, we get here 4 into e to power 1 into 2 is 4. So this gives me 8 e to power 4, and that's my result for the value of the function at point y. Actually, this is same as we say we want to find the tangent to the curve. Tangent to the curve, for example, in one dimension is f dash of x. At the point, we just put the value of x to get it. Here we want to find, for example, the same example. If we are asked find the slope of the tangent line to the curve at the point 1, 2. Along x-axis, along y-axis, the same thing. You have the partial derivative at the point 1, 2 r. We say slope of the tangent to the curve at point 1, 2, the same thing. So we are going to discuss the partial derivatives further. We have discussed partial derivative 2 variables. Now I'm going to discuss partial derivatives 3 variables. I explained before, we have 3 variables. Only one variable is if x, y, and z. We want to take the partial derivative with respect to x, when y is constant, z is constant. If you want to take partial respect to y, then my x is constant, z is constant. Only one variable is changing. I want to take z, then my x is constant, y is constant. All ideas as we discussed for 2 variables, we are going to apply for 3 variables. I have to take this example. We take the first partial derivative of the function of x, y, z, x squared, y cubed, z to power 4 plus 2x minus 5, y, z. Let us see how we take it. Number 1, we take partial derivative with respect to x, of the function x, y, and z. So if we take the function, so as I mentioned that we are having here the values of the value with respect to x is changing only, and not respect to, so I get here partial by partial x. I just explained it by this way, partial by partial x of x squared. Now y is constant and z is constant. Then we are having here plus partial by partial x of 2x. Then we have minus partial by partial x of 5 y z. Now when we take partial derivative with respect to x, we get here 2x. Then we are having here y is constant and z is constant. Then we take partial by partial x of 2x, that gives me only 2. And then partial x of 5 y z. 5 is constant, y is constant, z is constant. So that gives me minus 0. And my result will be equal to 2x y cube z to power 4 and plus 2. So that's my result. Now I take the second one. Second one is I want to find the partial derivative with respect to y of x, y, and z. Now I say I have the partial derivative with respect to y. I take the whole terms. Even I can take here the term including all of them. So here we can do like this. And here we have x squared plus y to power 3, no, x squared into y to power 3 and z to power 4. Then we're having plus partial y of 2x, then minus partial y of 5 y z. Now as we discussed in the last example, you can just see here only y is changing, x is not changing, z is not changing. So y cube, the derivative of y cube is 3y squared. So get here 3x squared, y squared, z to power 4. Z is not changing, x is not changing, plus. Now 2x, 2 is constant, x is constant. So the derivative with respect to y will be 0. Then minus. I have 5, y, and z. 5 is constant, z is constant, derivative of y is 1. So I get here 5, z. So rewrite this one. I get here 3x square y to power 2 z to power 4 minus 5z. So here in this case we are having only our y is changing. Now third case is here we want to find the partial derivative of this one when only z is changing with respect to z. So we have already discussed the partial derivative x and y in the last example. The first time we are going to discuss the derivative with respect to z. So get here partial pi, partial z, the first term, that's x square, y to power 3, z to power 4, plus partial by partial z of the term, second term, that's 2x. And then we having here minus partial by partial z of the third term is 5yz. Now we can see here only z is changing, x is not changing, y is not changing. We have z to power 4. We take derivative, we get here 4z to power 3. So I can write here 4x square y cube, no change, and derivative of z4 is 4z to power 3 plus 2 is constant, x is constant, only z is changing. We are taking partial derivatives, so value is 0 minus 5 is constant, y is constant, but z is changing. Derivative of z is 1, so get minus 5y. I rewrite this one. I can say this my result is 4x y cube z cube minus 5y. So this is my result of my problem. I have partial respect to x, partial respect to y, partial respect to z. This way having here 3 variables. We can have 4 variables, we can have 5 variables. The idea is same, only one variable will be changing and all the other 4 or 3 or 2 or 1 will be treated as constant. So we can apply the theory we have discussed, one with one variable in that one, and we can find partial respect to x, y, z, w, t, and so on. Any number of variables have. Only one variable will be changing at one time, all will be treated as constant. So there are many examples in my notes also. You can find the example in the book. Always I used to say that you can learn it by doing practice. You have to solve the problems. Solve the problem, you can master it. And there are many problems in each of the book given, many problems, and you must do the practice. And that practice makes the man perfect.